The PMM-300 together with the more compact PMM-305 make up our high-end devices for vibration monitoring. We have the ability to connect various sensors from our portfolio. For example, we can monitor relative shaft vibration, as demonstrated here with this rotating shaft. We measure vibration in both the X and Y directions, and additionally, with a speed sensor to create order tracking parameters, allowing us to capture the relative shaft vibration. Additionally, we can also measure absolute bearing vibration using acceleration sensors or vibration velocity sensors, meaning we can also connect IEPE sensors. Furthermore, we have the option to monitor the air gap, as demonstrated here with an air gap sensor. We can also use this to monitor winding heads. The PMM-300 has 4 sensor inputs of various types, along with a speed input. All the calculated parameters, such as a wide range from peak to peak or Smax, can be output via analog outputs, 4 to 20 milliamps. Additionally, we have buffered outputs on the front to transmit raw signals to another system. Digital outputs allow us to set alarm thresholds, such as for a shutdown or alarm. Through Modbus TCP or Modbus RTU, we can also integrate the data into other systems. Additionally, both devices can be connected to the CMS 500+ Orca system, a powerful vibration analysis software which can optionally be included. This allows you to collect the raw data from all acquisition devices in use and later conduct extensive vibration analysis. The more compact PMM-305 differs in that it lacks analog outputs, unlike the PMM-300. Nevertheless, we can still connect 4 sensors plus a speed sensor and calculate all the same parameters as with the PMM-300. The compact version also lacks the buffered outputs on the front, but Modbus TCP and Modbus RTU are still available, as well as the option to connect to the CMS 500+ software. In short, it is a more compact form for slightly less demanding applications. The PMM system in this compact form for the mounting rail can be extended modularly with additional devices via the rear panel bus. The entire acquisition system is also available in a 19-inch version called PMS for integration into 19-inch racks for larger systems. Now let's take a look at the PMx-300 Manager, the software for parameterizing all PMM and PMS devices. We are currently connected to the PMM-300. The software offers various settings with pre-configured operation modes. In this case, we are measuring relative shaft vibration twice and absolute bearing vibration twice. And you can select the appropriate pre-configured mode here, but if you want to measure 4 times the relative shaft vibration or 4 times the absolute vibration, you can choose templates accordingly. We've chosen the template for twice relative shaft vibration and twice absolute bearing vibration. You can also adjust the sampling rate, currently set to 496 samples per second, but it can go up to 24,576 samples per second. Under the External Communication tab, you can configure the device's interfaces to other systems, enabling Modbus and setting the format accordingly. Depending on the device configuration, you can also use Profibus DP for data transfer or OPCUA. If you want to parameterize a channel, in this case for vibration, for example, you can go to channel 1. Here you select a sensor, such as the standard sensors available from MC Monitoring, or you can connect your own sensor by selecting Other. The nice thing is if you choose a pre-configured sensor, the device automatically adjusts and you can start immediately. Under the Analog Output tab, you can configure the analog output by selecting the parameter you want to output. These parameters like min-peak, peak-to-peak, true RMS, Smax, etc. are automatically calculated based on the template. You don't need to do much additional configuration. On the right, you set the signal scaling, so you can adjust the analog output accordingly. Under the Alarm tab, you can configure a digital output for parameter thresholds, either for an alert or danger threshold, triggering different relays for alarm and danger. You can also configure various filters in pre-processing, such as low pass, high pass, band pass, or band stop filters, making sensor and device configuration relatively simple. The PMM-305 and other devices in the PMM and PMS series are essentially designed similarly. If you want to view the time signal during machine operation, you can click on the button at the top to monitor the time signals of the measured values. You also have the option to view the FFT or monitor the trend of the parameters. This gives you a good overview of the current measurements. For further diagnosis or vibration analysis, the CMS-300P Orca software would come into play, which we will demonstrate in a separate video.